Hello everyone. Today we will discuss about the plane stress and plane strain condition. What is meant by plane stress and what is meant by plane strain? In the previous classes, we already known about the what is plane stress and what is plane strain. We already studied in the strength of materials and mechanics of solid subject. So once we can recall it from that subject. So here plane stress is a type of load that is applied to a materials. Plane stress is a type of load that is applied to a material in this finite element method. So again we can define the plane stress conditions. So what is the use of plane stress and what is the use of plane strain conditions? Here in this chapter we will discuss about the plane stress and plane strain conditions in the finite element methods. The plane stress, it is defined to be a state of stress in which the normal stresses and the shear stresses directed proportional to the plane are assumed to be 0. Directed proportional to the plane are assumed to be 0. So here I am explaining about the plane stress conditions. So it is a defined to a state of stress in which the normal stresses and the shear stresses directly proportional to the plane are assumed to be a 0. So here in this diagram I am considering two diagrams, that means plate with hole and plate with fillet. Plate with hole and plate with fillet. The first diagram, the plate in the xy plane shows subjected to, so here this is the first diagram, plate with hole and plate with fillet. First of all we need to know about the plate with hole. The plate in the xy plane shown subjected to surface traction. So here T is the surface traction. So here T is the surface traction. It can represent it with capital T. Pressure acting on the surface edges. Pressure acting on the surface edges like this. Pressure acting on the surface edges or faces of a member in force per unit area. So here this is along the x-axis. In the planes are under the state of plane stress conditions. That is the normal stress sigma z and the shear stress tau x and tau y are assumed to be 0. Assumed to be 0. So here in this diagram, the plate with hole, so we can assume along the x-axis and along the y-axis. So here in this some thickness is there, that's why I am considering z direction. That's why I am considering z direction. In this normal stresses, sigma z direction is 0, as well as shear stresses is also connecting to the tau x, tau y and connecting to the tau xy and tau yz. So tau xy and tau yz are assumed to be 0. So in generally members that are members that are those with a small z direction compared to in plane x and y dimensions, compared to in plane x and y directions, and whose loads acting only in the x comma y direction, x comma y directions, x comma y directions. Use only on the x comma y plane can be considered to be under plane stresses, can be considered to be under plane stresses. And coming to the plane strain, so in the plane strain, shapes changes of a material happen on a single plane only. Its deformation in a particular direction is constrained. In a deformation in a particular direction is constrained. What is the plane strain? It is defined to be a state of strain in which the strain normal to the xy plane, thus sigma z, and the shear stress gamma xy, shear stress gamma xy and gamma yz are assumed to be 0. So here in the plane stress and plane strain conditions, we neglect the z directions. We neglect the z direction. That's why I am considering only xy plane. So in the sigma x and epsilon z and gamma xz and gamma yz are assumed to be 0. Assumed to be 0. The assumption of plane strain are realistic for the long bodies with constant cross-section area subjected to loads that acting only in the xy directions and do not vary in the z directions. Do not vary in the z directions. So in this diagrammatical representation, the pipe subjected to a vertical loads. In this example, only a unit thickness of the structure is considered because each unit thickness behaves initially. The finite element models of the structures in the figure consist of approximately discretized cross sections in the xy plane with the loads, xy plane with the loads acting over unit thickness in the x and y directions only, x and y directions only. So here in this diagram, the load acting along the x and y directions only. So here this can be transferred to a z direction, but because we are considering only two-dimensional analysis, that's why I am considering x and y coordinates. That means single plane. That means single plane. And the shape changes on a material happens on the single plane. That means single plane, the load is acting on the single plane. The deformation in a particular direction is constrained. The deformation in a particular direction is constrained. Now I am going to explain about the concepts of two-dimensional state of stresses and strain, and the stress strain relationship for plane stress and plane strain are necessary to understand the fully the development and applicability of the stiffness matrix for the plane stress and plane strain conditions. Plane stress and plane strain conditions. Plane stress and plane strain conditions. So here I am considering one plane, that means x and y directions, along the x direction and along the y direction. So here in this area along the x direction is represented with a displacement of u, that is horizontal displacement represented with u, and here the vertical deflection, that means along the y direction we can consider it as a v. Horizontal direction is u, and horizontal displacement is u, and vertical displacement represented with v. So here in this diagram we can consider displacement, horizontal displacement u and vertical displacement v. So here horizontal displacement u and vertical displacement v in the xy direction at point A. In the xy direction at point A, and to displace or extend an additional incremental amount. Additional incremental amount, that means dou u by dou x. That means dou u by dou x, dou u by dou x, and AB and AB dou v by dou y into dy along the AB, and dou v by dou y into AC direction only. AC direction. So here in this diagram, the dou u by dou x into dx, dou u by dou x into dx along the AB direction, along the AB direction, along the AB direction, and dou v by dou y into dz along the line of AC directions. AC direction in the x and y coordinates. It is observed that the line AB, so here observe that the line AB and AC, line AB and AC, we seen that point B moves, the point B moves upward an amount of dou v by dou x into dx. So it can lifted along the y direction. That means we can change the dou u by dou x into dx with respect to with respect to a point and point C. So here it can represented with point C. It moves to the right an amount of dou u by dou x. So here the C point is moves along the x direction. That's why I am considering the displacement value dou u by dou y into dy with respect to C point, with respect to C point. So here in the deformation area, A can change it as a dash, and B can change it as a B dash, and C is the C dash, and D is the D dash. D is the D dash. So here I'm calculating strain conditions. So here what is the strain formula? The strain is the change in length by original length. The strain is the change in length by original length. So consider from this diagram, consider the line element AB in the x direction. AB in the x direction. AB in the x direction. So what is the strain formula? Change in length by original length. So here along the x direction, that's why I am considering epsilon x is equal to from the diagram change in length by original length. What is the change in length? So here change in length is equal to epsilon x is equal to change in length a dash b dash minus ab. So here a dash b dash is the change in length minus original length by original length. So here a dash b dash minus ab by ab. సో ఇక్కడ మనం డయాగ్రామాటికల్ గా అబ్జర్వ్ చేస్తే, సో ఇక్కడ ఏంటంటే ఏబి పొజిషన్ నుంచి ఏబిసిడి అనే ఒక స్క్వేర్ కాంపోనెంట్ ని ఆ స్క్వేర్ ఎలిమెంట్స్ ని నేను కన్సిడర్ చేసినప్పుడు సమ్ డిఫ్లెక్షన్ వల్ల అది ఏ మూమెంట్కి వెళ్ళింది. సో ఇక్కడ నేను స్క్వేర్ కన్సిడర్ చేస్తే అది ఇంక్లైన్ పొజిషన్లోకి వెళ్ళినప్పుడు ఏ డాష్ బి డాష్ సి డాష్ డి డాష్ కింద కన్సిడర్ చేశాను. సో ఇక్కడ ఎప్సిలాన్ ఎక్స్ అంటే స్ట్రెయిన్ వాల్యూ క్యాలిక్యులేట్ చేయమన్నప్పుడు ఎక్స్లాన్ ఎక్స్ అంటే ఎప్సిలాన్ ఎక్స్ ఈజ్ ఈక్వల్ టు ఏ డాష్ బి డాష్ మైనస్ ఏబి. సో అంటే చేంజ్ ఇన్ లెంత్ అన్నప్పుడు మనకి ఏ పాయింట్ నుంచి ఏ పాయింట్ చేంజ్ అయిందో డిస్టెన్స్ కావాలండి. సో అప్పుడు అది కావాల్సి వచ్చినప్పుడు ఏం చేస్తానండి, చేంజ్ ఇన్ లెంత్ పొజిషన్ అంటే ఏం తీసుకున్నాను నేను ఇక్కడ, చేంజ్ ఇన్ లెంత్ పొజిషన్ అంటే ఏ1 టు ఏ డాష్ టు బి డాష్ మైనస్ వాట్ ఈస్ ద ఒరిజినల్ లెంత్ ఏ టు బి. సో అంటే ఇది ఏ పొజిషన్కి చేంజ్ అయింది అన్నది చేంజ్ ఇన్ లెంత్ మనకు కావాలి. సో అందుకని ఇక్కడ నేను ఏం చేస్తాను అంటే ఏ డాష్ బి డాష్ మైనస్ ఏబి బై ఏబి, ఏబి బై ఏబి. సో ఇక్కడ నేను ఏం చేస్తానో చూడండి, ఏ డాష్ బి డాష్ లెంత్ అలా ఐడెంటిఫై చేస్తున్నాం. సో ఏ పొజిషన్ నుంచి బి డాష్ పొజిషన్కి ఇక్కడ నాకు ఏమవుతుందండి, ఏబి అనేది డిస్టెన్స్ డిఎక్స్తో రిప్రజెంట్ చేస్తే, సో రిమైనింగ్ లిఫ్ట్ అయిన ఏరియాని నేను యూ ప్లస్ డో యూ బై డో ఎక్స్ ఇంటూ డిఎక్స్గా రిప్రజెంట్ చేస్తున్నాను. అంటే ఇది ఏమవుతుందండి, ఈజ్ ఈక్వల్ టు ఏ డాష్ బి డాష్ ఈజ్ ఈక్వల్ టు యూ ప్లస్ డో యూ బై డో ఎక్స్ ఇంటూ డిఎక్స్. So we can substitute these a dash b dash value in the strain equation. So a dash b dash value in the strain equation, dx plus dou u by dou x into dx. This is the a dash b dash value. And what is the ab value? So here ab distance is represented with dx. That's why I am substituting ab is equal to dx. AB is equal to dx whole divided by AB is equal to dx. So here in this equation we can take it from this a dash b dash minus AB. So here dx is the common factor. So that's why I am considering dx of 1 plus dou u by dou x minus 1 whole divided by dx. So here dx get cancelled and 1 minus 1 get cancelled. So here epsilon x is equal to dou u by dou x. So here u represent displacement value and x represents the direction of the displacement. So here x is along the u is along the x axis. That's why I am considering dou by dou x of dou by dou x of u, dou by dou x of u. That's why epsilon x is equal to dou u by dou x. So here u displacement with respect to along the x direction. So consider the line element AC in the y direction. Similarly we can consider it from this diagram. So here A to C is the dy, A to C height is the dy, and A to C dash is the dy plus v plus dou v by dou y into dy. So we can substitute these formulas a dash c dash minus ac by ac. So here dy plus dou v by dou y into dy minus dy whole divided by dy. dy get cancelled and 1 and minus 1 get cancelled. So here dou v by dou y. So epsilon y is equal to dou v by dou y. So here this is the vertical displacement value v along the y direction. Along the y direction, that's why I am considering epsilon y is equal to dou v by v means vertical deflection and dou y represents along the y direction only. The shear strain gamma xy is defined to be the change in the angle between two lines such as AB and AC that originally formed a right angle triangle. Hence from the figure we can see gamma xy. So here once we can observe this diagram, erase all the lines. the shear strain gamma xy is defined to be a change in the angle between two lines such as AB, angle between the AB and AC. So here this is the triangle, right angle triangle, and this one is also right angle triangle. This one is also right angle triangle. So here we are having two triangles like this. So that's why I am considering angle between two lines such as AB and AC. That means A dash to B dash and A dash to C dash. Hence the figure we can see gamma xy in the sum of two angles. Sum of two angles. That's why I am considering gamma xy is equal to, so dou V by dou x. So here the vertical deflection is along the x direction plus the horizontal deflection or displacement along the y direction. So here this is the gamma xy is equal to dou v by dou x plus dou u by dou y. In the strain vector column matrix, epsilon x is equal to epsilon is equal to epsilon x plus epsilon x in the matrix form epsilon x, epsilon y and gamma xy. సో ఇక్కడ మనకి డెరివేషన్కి వచ్చేసరికి చూడండి అన్న, దీని మీద మనకి ప్రాబ్లమ్స్ ఉంటాయండి. సో ఫస్ట్ డయాగ్రామ్ అబ్జర్వ్ చేస్తే స్ట్రెయిన్ వాల్యూ క్యాలిక్యులేట్ చేయమన్నప్పుడు చేంజ్ ఇన్ లెంత్ పై ఒరిజినల్ లెంత్ ఫార్ములా తీసుకుని చేస్తున్నాను. సో ఇక్కడ ఈ డయాగ్రామ్లో సో నేను పింక్ కలర్లో హైలైట్ చేసిన క్యూబ్ ఏదైతే ఉందో ఏబిసిడి, దాన్ని చేంజ్ ఇన్ పొజిషన్ కింద డిఫైన్ చేసినప్పుడు ఇక్కడ డయాగ్రామాటిక్ గా ఏబి డిస్టెన్స్ ని డిఎక్స్ కింద రిప్రజెంట్ చేస్తున్నానండి. ఏ అనే పాయింట్ నుంచి బి డాష్ అనే పాయింట్ కి ఎంత డిస్టెన్స్ ఉందో కావాలి కాబట్టి సో డిఎక్స్ వాల్యూ ఏబి అలా ఉంచి రిమైనింగ్ ఎంత చేంజ్ అయింది అన్నది పొజిషన్ మూవ్మెంట్ ఉంది అన్నది యూ ప్లస్, అంటే అలాంగ్ ద ఎక్స్ యాక్సిస్ అన్నాం కాబట్టి ఇక్కడ డిస్ప్లేస్మెంట్ యూతో రిప్రజెంట్ చేస్తానండి. యూ ప్లస్ dou u by dou x అంటే partial differentiation with respect to first element, that equal to u plus dou u by dou x into dx. సో అలాగే ఇక్కడ సో హారిజాంటల్ గా ఉన్న ఏబి పాయింట్ సమ్ డిఫ్లెక్షన్ వల్ల మనకి ఏమవుతుందండి, ఇంక్లినేషన్ యాంగిల్ కింద వచ్చిందండి. సో ఈ హైట్ అంతా డిఫైన్ చేయాలి. సో ఇది y డైరెక్షన్ లో లిఫ్ట్ అయింది కాబట్టి డో వి బై, అంటే వెర్టికల్ అన్నప్పుడు y డైరెక్షన్ లో అన్నప్పుడు v తీసుకోవాలండి, ఎక్స్ డైరెక్షన్ అన్నప్పుడు యూ తీసుకోవాలి. సో ఇది వెర్టికల్ డైరెక్షన్ లో సమ్ హైట్ లిఫ్ట్ అయింది కాబట్టి డో వి బై డో ఎక్స్ ఇంటూ డిఎక్స్, అంటే ఇక్కడ వెర్టికల్ గా డిఫ్లెక్షన్ ఉన్నా సరే అది అలాంగ్ ది ఎక్స్ యాక్సిస్ మూవ్ అవుతుంది కాబట్టి డో వి బై డో ఎక్స్ ఇంటూ డిఎక్స్ వాల్యూ తీసుకున్నాను. సేమ్ అలాగే ఇక్కడ కూడా సి పాయింట్ దగ్గర ఇది హారిజాంటల్ గా మూవ్ అవుతుంది, అంటే అలాంగ్ ద ఎక్స్ యాక్సిస్ దగ్గర డిస్ప్లేస్మెంట్ ఏమవుతుంది యూ, అంటే డో యూ బై డో వై ఇంటూ డివై. సో ఈ ట్రయాంగులర్ ఎలిమెంట్స్ ని మనం డిఫైన్ చేసినప్పుడు ఫస్ట్ ఏం చేస్తామంటే ఇక్కడ ఎప్సిలాన్ ఎక్స్ ని ఎప్సిలాన్ వై ని క్యాలిక్యులేట్ చేయాలండి, చేంజ్ ఇన్ లెంత్ బై ఒరిజినల్ లెంత్. సో డయాగ్రామాటికల్ గా తీసుకుంటే ఎప్సిలాన్ ఈక్వల్ టు డో యూ బై డో ఎక్స్, అంటే యూ అనేది హారిజాంటల్ డిస్ప్లేస్మెంట్ అయితే అది అలాంగ్ ది ఎక్స్ యాక్సిస్ అయితే ఎక్స్ తీసుకుంటామండి. సో అలాగే ఎప్సిలాన్ వై అనేది వెర్టికల్ రిఫ్లెక్షన్ కాబట్టి వై అంటే వెర్టికల్ కాబట్టి సో వెర్టికల్ రిఫ్లెక్షన్ వీతో రిప్రజెంట్ చేస్తున్నాను అలాంగ్ ద వై యాక్సిస్. సో అలా కాకుండా షియర్ స్ట్రెయిన్ క్యాలిక్యులేట్ చేయమన్నాడు అనుకోండి, షియర్ స్ట్రెయిన్ క్యాలిక్యులేట్ చేయమంటే మనం ఏం చేస్తామండి, షియర్ స్ట్రెయిన్ ఏబి ట్రయాంగిల్ కి, అంటే ఏబి లైన్ తీసుకుంటే ఏ డాష్ బి డాష్ కి ఏ డాష్ ఈ డాష్ దగ్గర రైట్ యాంగిల్ ట్రయాంగిల్స్ వస్తున్నాయండి. సో ఆ ట్రయాంగిల్స్ ని డిఫైన్ చేసినప్పుడు ఏంటంటే సమ్ టైమ్స్ అలాంగ్ ద ఎక్స్ యాక్సిస్ మూవ్ అవుతాయి, సమ్ టైమ్స్ అలాంగ్ ద వై యాక్సిస్ డిఫ్లెక్షన్స్ ఉంటాయండి. సో అప్పుడు షియర్ స్ట్రెయిన్ అన్నప్పుడు రెండు కలిపి మిక్స్ చేయమన్నాడు అనుకోండి, అంటే షియర్ స్ట్రెయిన్ అలాంగ్ ద ఎక్స్ అండ్ వై డైరెక్షన్ అన్నాడు అనుకో, అప్పుడు మనం ఏం చేస్తామంటే ఎక్స్ ని వీతోని వైని యూతోని చేయాలండి, అంటే డిస్ప్లేస్మెంట్ వెక్టర్స్ డైరెక్షన్ బట్టి చేంజ్ అవుతున్నాయి. ఇప్పటి వరకు ఎప్సిలాన్ ఎక్స్ అన్నప్పుడు అలాంగ్ ద ఎక్స్ యాక్సిస్ అంటే ఓన్లీ యూ ఒకటే తీసుకున్నాం అండి. సో అలాగే అలాంగ్ ద వై యాక్సిస్ అంటే ఓన్లీ వి ఒకటే తీసుకున్నాం. సో అలా కాకుండా షియర్ స్ట్రెయిన్ అలాంగ్ ద ఎక్స్ అండ్ వై ప్లేన్ అని ఇస్తే సో అప్పుడు మనం ఇక్కడ ఏం చేస్తామంటే ఎక్స్ కి ఆపోజిట్ లో యూ వస్తుందండి, వై కి ఆపోజిట్ లో యూ వస్తుంది. ఎక్స్ కి ఆపోజిట్ లో వి, వై కి ఆపోజిట్ లో యూ వస్తుంది. సో గామా xy ఈజ్ ఈక్వల్ టు డో v బై అంటే వెర్టికల్ డిఫ్లెక్షన్ ని విత్ రెస్పెక్ట్ టు x డైరెక్షన్ తో చేస్తాం ప్లస్ హారిజాంటల్ డిస్ప్లేస్మెంట్స్ ని విత్ రెస్పెక్ట్ టు y తో చేయాలండి. సో గుర్తుపెట్టుకోండమ్మా. సో గామా xy ఈజ్ ఈక్వల్ టు డో v బై డో x vertical displacement with respect to x axis plus horizontal displacement with respect to y. So the strain velocity column matrix the strain vector column matrix epsilon is equal to epsilon x, epsilon y and gamma xy. This is the plane stress and plane strain condition. Now we will discuss about the simple problems on the plane stress and plane strain conditions. Epsilon x value and epsilon y value gamma x comma y. These are the unknown. Note on the first problem. If a displacement field in described by u equal to minus x square plus 2y square plus 6xy into 10 power minus 4 and vertical displacement v equal to 3x plus 6y minus y square into 10 power minus 4, determine the epsilon x, epsilon y, gamma xy at the point x equal to 1 and y equal to 0. So మనం ప్రీవియస్ గా ప్లేన్ స్ట్రెస్ ప్లేన్ స్ట్రెయిన్ కండిషన్ ఎలా అయితే క్యాలిక్యులేట్ చేసామో సో ఆ ఫార్ములాస్ యూజ్ చేసి ఇక్కడ మనం ప్రాబ్లమ్ సాల్వ్ చేస్తాం. సో ప్రాబ్లం నెంబర్ 1.
Described by u equal to minus x square plus 2y square plus 6xy into 10 power 4, v equal to 3x plus 6y minus y square into 10 power minus 4. Determine the epsilon x, epsilon y, gamma xy at the point of x equal to 1 and y equal to 0. So here we need to calculate epsilon x value and epsilon y value and gamma x comma y. These are the unknown terms. So here in this problem we need to calculate epsilon x, epsilon y and gamma xy. So here first one epsilon x. So here what is the u value? Minus x square plus 2y square plus 6xy into 10 power minus 4. So here, so in this diagram, so this is the x axis, this is the y axis. We can represent it as a epsilon x and epsilon y. So here this is the horizontal displacement represented with u. This is the vertical displacement represented with v value. So horizontal u, vertical v. So here, so in this diagram we need to calculate epsilon x is equal to partial derivative of dou by dou x. This is the along the x direction with respect to u. So here epsilon x is equal to dou by dou x into u. So here what is the u value? U value is equal to dou by dou x of what is the a value? Minus x square plus 2y square plus 6xy into 10 power minus 4 into 10 power minus 4. So here epsilon x is equal to, here epsilon y is equal to dou by direction, y direction into displacement vector v. So what is the v value? Minus 3x plus 6y minus y square into 10 power minus 4. This is the epsilon y value. So here gamma xy. So here in this diagram, this is the dou u by dou v by dou x, dou v by dou x. So here dou u by dou y. This is the along the x direction, this is the along the y direction. So coming to the problem, so here first one, xx is equal to dou by dou x of u and yy dou by dou y of v gamma xy is equal to dou by dou x of v plus dou by dou y of u. This is the formulas we need to calculate epsilon x, epsilon y and gamma xy. So we need to substitute u value. What is the u value? So here dou by dou x into u value minus x square plus 2y square plus 6xy into 10 power minus 4. So here the partial derivative with respect to x. What is the x values? Minus x square and plus 6xy. So here no need to calculate y value. So that's why here partial differentiation with respect to x, minus 2x plus 6 into y. So here 6 into y, that equal to minus 2x plus 6y into 10 power minus 4. This is the epsilon x value. So here what is the epsilon x value? Dou u by dou y. What is the v value? This is the v value is equal to dou by dou y. Partial differentiate with respect to y, with respect to y. So here what is the y displacement value? Y along the y direction, the displacement value v. So here v equal to 3x plus 6y minus y square into 10 power minus 4. So here partial differentiate with respect to y. So here x value 0. So 6y, 6 minus 2y into 10 power minus 4. 10 power minus 4. So third value dou by dou x of v. So here dou by dou x of v, dou by dou x of v and dou by dou y of u. So here what is the dou by dou x value into v? So here v value is 3x plus 6y minus y square into 10 power minus 4 plus dou by dou y of what is the u value? What is the u value? U minus x square plus 2y square plus 6xy into 10 power minus 4. So partial differentiate with respect to x. So here with respect to x, no need to calculate y values. 3 into 10 power minus 4 plus y values. So this is the 0. Partial differentiation with respect to y. 4y plus 6x into, here y value is 1 is equal to 4y plus 6x into 10 power minus 4. So what is the value? So here 6x plus 4y plus 3 into 10 power minus 4. 10 power gamma xy is equal to 6x plus 4y plus 3 into 10 power minus 4. This is the second one and third one. So we need to substitute at the point x equal to 1. So here sigma x, here epsilon x is equal to this value, epsilon y is equal to this value. So we need to substitute x equal to 1 and y equal to 0. So we need to substitute x equal to 1 and y equal to 0. So here minus 2 into x. So here x equal to 1, y equal to 0. Epsilon x is equal to, here x equal to 1, y equal to 0. So minus 2 into 10 power minus 4. Minus 2 into 10 power minus 4. What is the epsilon y value? So here epsilon y value, we need to substitute these points. X equal to 1 and y equal to 0. So epsilon y is equal to, so here y value is 0. Y value 0. So 6 into 10 power minus 4. 6 into 10 power minus 4. So here we need to substitute at point x equal to 1, y equal to 0. So here x equal to 1, y equal to 0, that equal to 6 plus 3. So here this is the 0 into 4, 0 is into 10 power minus 4, that equal to gamma xy is equal to 9 into 10 power 4. This is the answer for this problem. If a displacement field is described by u equal to minus x square plus 2y square plus 6xy into 10 power 4, v equal to 3x plus 6y minus y square into 10 power minus 4. Determine the epsilon x, epsilon y and gamma xy at the point x equal to 1 and y equal to 0. So here these are the three final values. These are the three final values. So here epsilon x, epsilon y, gamma xy is equal to epsilon x value minus 2 into 10 power minus 4, epsilon y value 6 into 10 power minus 4, gamma xy value 9 into 10 power minus 4. Next problem. A displacement field u equal to 1 plus 3x plus 4x cube plus 6xy square, v equal to xy minus 7x square. Determine first one. Write down the expressions for epsilon x, epsilon y, gamma xy. Son, find the epsilon x is a maximum within the square. Find where the epsilon x is a maximum within the square. So here in this problem we have given one square. So with the dimensions of -1, -1 and 1 and 1. So here two coordinates are there. So in this point, this is the 0, 0. So here along the x direction and along the y direction. So here along the x direction, displacement value u is equal to 1 plus 3x plus 4x cube plus 6xy square. Along the y direction, displacement v equal to xy minus 7x square. So this is the square diagram. So here 2 points are there, that is -1, -1 and 1, 1. So coming to the first question. Solution. First question. A. Write down the expression for epsilon x. So here epsilon x is equal to, what is the formula for epsilon x? Dou by, here x, dou x of u. So here dou u by dou x. So partial differentiate with respect to x, that equal to dou by dou x of, what is the u value? So here u value is equal to 1 plus 3x plus 4x cube plus 6y square. So here u equal to 1 plus 3x plus 4x cube plus 6xy square is equal to, so with partial differentiate with respect to x, partial differentiate with respect to x. So here constant value 0, constant value 0. So only 3 x's are there. So here, so in this equation, partial differentiate constant term 0, 3 into d by dx of 3x, that equal to 3, plus what is the dou by dou x of 4x cube. So here 4 into 3, 12x square plus 6y square. 6y square. We need to simplify it. So here constant term dou by dou x of dou by dou x of 1 plus dou by dou x of 3x plus dou by dou x of 4x cube plus dou by dou x of 6xy square. Dou by dou x of 6 xy square. So here this is the constant term, that's why 0 plus dou by dou x of 3x with the x of 3 plus dou by dou x of 4x cube. So what is the dou by dou x of 4x cube? This is 12 into x square plus dou by dou x of with respect to x. So here 6 y square is constant term, dou by dou x of x equal to 1. So here 1. So finally we get it from this equation 3 plus 12x square plus 6y square. So this is the epsilon x value. 3 plus 12x square plus 6y square. This is the epsilon x value. So here dou by dou x of any constant term is equal to 0. That's why here dou by dou x of 1 equal to 0, dou by dou x of x equal to 1. This is the simplification of this equation. So next one, epsilon y. So here epsilon y is equal to, what is the formula? Dou by dou y with respect to y. So here y. What is the displacement of y direction along the y direction? V. V is equal to dou by dou y of, what is the V value? xy minus 7x square is equal to, so here partial differentiate with respect to y. So here x is the constant term into y is dou by dou y of y equal to 1 minus, so in this equation this is the x term, this is the x term that equal to 0. So finally this equation x only. Coming to the third one, so here gamma xy is equal to dou by dou x of v plus dou by dou y of u is equal to, so here dou by dou x, this is the opposite term v, this is the along the x direction. So here gamma xy is equal to dou by dou x of v plus dou by dou y of u is equal to, this equation is equal to, so here dou by dou x of v value, what is the v value? xy minus 7x square plus dou by dou y of, what is the u value? What is the u value? 1 plus 3x plus 4x cube plus 6xy. 6xy. We need to simplify that. Is equal to, with respect to x, partial differentiate with respect to x. So here y minus 7 into 2, 14x plus with respect to y, this is the constant term, this is the constant, this is the x term, this is also constant term. So here this is also constant term. So here 6 into xy. So here 6 is here constant term, 6x here constant term 6x So here, what is the u value? 1 plus 3x plus 4x cube plus 6xy square. 6xy square. So here, with respect to y, 6 into 2, 12. 12 into x. 12 into x. Y minus 14x plus 12 into x, that equal to gamma xy is equal to y minus 2x. Y minus 2x. Y minus 2x. What is the first question? So here epsilon x, epsilon y, gamma xy is equal to, what is the epsilon x value? 3 plus 12x square plus 6y square. Epsilon y equal to x, gamma xy, y minus 2x. This is the first question. So coming to the second question, find where epsilon x is a maximum within the square. So here, find the epsilon x maximum within the square. So what is the epsilon x value? 3x plus 12x square plus 6y square. B bit epsilon x is a maximum within the square. So here epsilon x is equal to 3 plus 12x square plus 6y square. 3 plus 12x square plus 6y square. We need to substitute these square values. We need to substitute these square values. So what is the square values at point? At point minus 1 comma minus 1. So we need to substitute this value in this equation. So epsilon x equal to 3 plus 12 of, what is the x value? This is x and this is y. X value is minus 1 whole square plus 6 into minus 1 whole square, that equal to 3 plus 12 plus 6. 15 plus 6, 21. What is the second point value? At point 1 comma 1, epsilon x equal to 3 plus 12 into 1 whole square plus 6 into 1 whole square, that equal to 3 plus 12 plus 6 is equal to 21. So these are the 2 points. Some other points we need to calculate. So we will check it for the these values maximum or not. So here this is the square. So here x axis and y axis, these are the point minus 1 and minus 1. These are the point 1 comma 1. So we need to check it 21 is the maximum or not. So here, so this point is minus 1 comma minus 1. This point is plus 1 comma minus 1. This point is 1 comma 1. This point is minus 1 comma plus 1. We need to check another 2 points. So here epsilon x is the maximum or not. Epsilon x value is 21 is maximum or not. What are the remaining 2 points? We need to calculate another 2 points. That means plus 1 minus 1 and minus 1 plus 1. So here at point here at point 1 comma minus 1 epsilon x is equal to, so here 3 plus 1, 12 into 1 whole square plus 6 into minus 1 whole square, that equal to 21. Set point at point minus 1 plus 1, so minus 1 plus 1 epsilon x equal to 3 plus 12 of minus 1 whole square plus 6 of 1 whole square, that equal to 21. So here epsilon x value, so normal strain value is maximum at the end of the edges, so maximum at the end of the edges. So here the normal strain epsilon x is maximum at the end of the edges, that equal to epsilon x maximum is equal to 21. Epsilon x maximum equal to 21. Next problem. Develop a deformation field u x comma y v of x comma y that describes the deformation of the finite element shown in the figure. From this determine epsilon x, epsilon y and gamma xy. We need to calculate these three values. So here epsilon x is unknown term, epsilon y is unknown term and gamma xy is unknown term. So here in this problem we have two different diagrams, that is non-deformation and deformation diagrams. So here the origin point is 0, 0 and second point is 5, 0 and third point 5, 10 and 0, 10. After deformation you can convert it into 4, 0, 9, 0, 10, 10 and 5, 10. So this is the given problem. So here non-deformation and deformation. Now we need to calculate epsilon x, epsilon y and gamma xy. So we need to calculate these three terms. So without knowing the u term and v term, so these are the displacement fields. So some 1 plus x plus y plus some 4x square plus 4y square plus something. So in the previous problems they mentioned u and v values in this form. So in this problem we cannot give any this type of relations. So we cannot give any this type of relation. So in this problem, So now we can solve. So here development A, deformation field u of xy and v of x comma y. So here in this diagram, so in this non-deformation diagram, so these are the 0 comma 0 and 5 comma 0 and 5 comma 10 and 0 comma 10. This is the non-deformation body. So here along the x direction u and along the y direction displacements along the x direction displacement u, along the y direction displacement v. So now we need to calculate the u of x comma y and v of x comma y. We need to calculate u of x comma y, v of x comma y. So here in this equation, we can convert it into, so this is the x and y, x comma y, x comma y and x comma y. So here we can represent horizontal displacement with respect to u1, horizontal displacement with respect to u2, horizontal displacement with respect to u3, horizontal displacement with respect to 4 value. So here x1 y1, x2 y2, x3 y3, x4 and y4. So here in this diagram, what is the coordinates? Here coordinates 0 comma 0, 5 comma 0, 5 comma 10 and 0 comma 10. These are the coordinates, and displacements u comma v, displacements u comma v. So here first one u1 comma v1, second one u2 comma v2, so third one u3 comma v3, and last one u4 comma v4. These are the displacement values. Similarly, so here u1 equal to 0, v1 equal to 0, u1 equal to 0, v1 equal to 0. So here u2 is equal to 5, v2 is equal to 0. So here u3 is equal to 5, v3 is equal to 10, u4 is equal to 0, v4 is equal to 10. These are the displacemental values. Now we need to calculate. So here a deformation field u of x comma y, v of x comma y that describes the two-dimensional finite element, two-dimensional finite element is described by polynomial equation. Polynomial equation. So here u of x comma y is equal to u1 plus u2x plus u3y plus u4 x square. This is the polynomial equation. So I'm coming to the next one. V of x comma y is equal to, so here v1 plus v2x plus v3y plus v4 x square. These are the polynomial equations we already studied in the intermediate and engineering first year. The polynomial equation in the two-dimensional values u of x comma y. So here clearly mentioned deformation field u of x comma y. From the polynomial equation, u of x comma y is equal to u1, u2x, u3y and u4 x square. Similarly, v of vertical displacement v of x comma y equal to v1 plus v2x plus v3y plus v4 x square. So here, what is the u naught value? We can substitute these values in this equation. So here, what is the u1 value? u1 value is 0 plus, what is the u2 value? 5. What is the u1 value? So here u1 equal to 0 plus u2x. u2 means 5x plus u3 equal to 5 into y plus u4 equal to 0 into x square 0. That equal to the final equation u of x comma y equal to 5x plus 5y. 5x plus 5y. Coming to the next one. So here vertical displacement v of x comma y equal to v1. So here what is the v1 value? v1 equal to 0 plus v2 equal to 0 into x 0 plus, what is the v3 value? So here v3 equal to 10 into y plus, what is the v4 value? v4 value 10 plus 10 into x square is equal to 10y plus 10x square. 10y plus 10x square. These are the polynomial equations. So here, after completion of these polynomial equations, we need to calculate epsilon x, epsilon y and gamma xy. Epsilon x, epsilon y, gamma xy. So here, what is the u of x comma y value is equal to 5x plus 5y. What is the v of x comma y value? 10y plus 10x square. 10y plus 10x square. So here this is the epsilon x and this is the epsilon y. So now we need to calculate these two values. We need to calculate these two values. Epsilon x is equal to dou by dou x of u of x comma y. U of x comma y. What is the u of x comma y value? So here dou by dou x of 5x plus 5y. 5x plus 5y, that equal to, with respect to partial differentiate with respect to x. So here the epsilon x is equal to 5. Epsilon x is equal to 5. So epsilon y dou by dou y of v of x comma y. So here in this first equation, along the x direction displacement u, in the second equation along the y direction displacement v. So equal to dou by dou y of, what is the v of xy value? 10y is 10y plus 10x square. So here this is the dou by dou y of 10y means 10. This is the constant term, that is 0. So here epsilon y equal to 10. Epsilon y equal to 10. So here in this equation, so epsilon x, epsilon y equal to 10. So here epsilon x and epsilon y. After that we need to calculate gamma x y. So here what is the value of gamma xy? Dou by dou x of v of x comma y plus dou by dou y of u of x comma y. U of x comma y. So here dou by dou x of, what is the v x comma y value? 10y plus 10x square plus dou by dou y value, dou by dou y of u value 5x plus 5y, 5x plus 5y. So 5x plus 5y. So here dou by dou x of 10 into x square, that equal to 20 into x plus dou by dou y of 5x plus 5y. This is a x1, this is a 5y, that means 5. So here gamma xy is equal to 20 x plus 5. 20 x plus 5. This is the constant term. This is the constant. In this figure, the deformation occurs at the figure. In this figure, the deformation occurs at the deformation occurs at the points 4, 0, 9, 0, 5, 10 and 10, 10. So here in the non-deformation body, so 0 comma 0, deformation body 4 comma 0. We need to calculate 4 comma 0 is the deformation value. X equal to 4 comma y equal to 0. Some remaining points, x equal to 9, y equal to 0. X equal to 10, y equal to 10. And last point, x equal to 5 and y equal to 10. So here this is the x1, y1, x2, y2, x3, y3, x4, y4. So here x1, x2, x3, x4, x5, sorry, y1, y2, y3, y4. So here in this equation we need to substitute these values. So here gamma xy is equal to, so here 20 into x. So here what is the x value? 4. Here what is the x value? 4. 20 into 4 plus 5 is equal to 80 plus 5, 85. So coming to the next one, gamma xy is equal to 20 into 9 plus 5. So 20 into 9, 185. So here coming to the third one, gamma xy 20 into 10 plus 5, 205. So coming to the third one, gamma xy is equal to 20 into 5 plus 5 equal to 20 into 5, 5 into 100 plus 5, 105. So in this deformation figure, the deformation occurs at these 4 points. So here what is the minimum value? This is the minimum value. So we can consider it as a epsilon x, epsilon y, gamma xy is equal to, what is the epsilon x value? 5. Epsilon y value 10. What is the gamma xy value? This is the minimum value. So we need to write in this way. So this is the solution for unknown parameters of the u of xy comma v of xy. We need to determine epsilon x, epsilon y and gamma xy.